Hello and welcome to lesson 4.2, solving linear trigonometric equations. So today what we're going to do is we're going to solve some linear trig equations. Linear trig equations are in the forms sine x equals something, cos x equals something, or tan x equals something, or even cosecant equals something, cotangent equals something, secant x equals something, where we're not going to have exponents of 2 or higher. So we're going to solve these both algebraically and graphically. So first off, what we can do is we can rearrange this expression tan x minus 1 equals 0 into tan x equals 1. And we want to solve this on the domain 0 to 2 pi. So we're going to look at what this looks like. We're going to look at where y equals tan x and y equals 1 intersect. That's what it's actually looking at. Okay, so here I have a drawing of y equals tan x and y equals 1. You can see y equals tan x in the blue and y equals 1 in the red. And you can see these actually intersect at these points right here. This one turns out to be at pi over 4, and this one turns out to be at 5 pi over 4. So what we're going to do is we're going to use our calculators to actually find this value out and verify this number turns out to be exactly what we need, and how we can solve it using our calculators. So in order to solve for x, what you're using is tan inverse of x, or arctangent of 1. Now if you plug it into your calculator and you do tan inverse of 1, make sure it's in radian mode, you should get a value like 0.785 approximately. Well, if you're not aware, if you divide this value by pi, you're going to get a value of 0.25. So that means that this is, in terms of pi over 4, or 1/4 of pi. Now by default, calculators automatically give you the answer in terms of the lowest angle closest to 0 in the first, second, or fourth quadrants. It'll never ever give you an angle in the third quadrant. So pi over 4 is this angle. Now, according to my cast rule, that means my other solution, tangent, is also positive in my third quadrant. And my related acute angle also turns out to be pi over 4. It's the exact same size angle that we get. The related acute angles will always be the same, it's just the angles themselves might not be the correct one. So to find the other possible angle, the other solution for this, all you have to do is take your value of pi over 4, or 0.785, and add pi. Because this big angle right here is pi units, meaning the overall angle that you need here is pi plus the pi over 4, which is 5 pi over 4, or if you wish, 3.927. And that's how you go about solving this. Okay, so let's take a look at some more examples here. So first of all, we've got to rearrange these equations so that we can get sine x by itself. So I'm going to divide both sides of this by 4. So I get sine x minus 1 equals negative 3/4. I can add 1 to both sides, 1/4. So in order to solve for x, I do the sine inverse, or arc sine, of 1/4. This one does not actually relate to a special triangle. So when we do the sine inverse of 1/4, I get a approximately 0.253. So this related acute angle is 0.253. Again, by cast law, we know sine is also positive in our second quadrant. That related acute angle is still 0.253. So the other angle here, the big one right here, can be calculated by taking the value of pi and subtracting that approximation of 0.253, which gives you approximately a value of 2.889. Okay, let's try that again, only thing with a little bit more challenging problem. Here we get 2 sine 2x equals 1, and I want to find out that values of x on the domain 0 to pi. Well, in order to do this, first change this to 2 sine theta equals 1. You can solve this by sine theta equals a half. Again, theta equals sine inverse of a half, or arcsine of a half. And if you work it out, it's 0.524 approximately, or if you wish, pi over 6. Again, by the cast rule, sine is positive in 2 quadrants. You know this one is pi over 6. That means the related acute angle is also pi over 6. So our other value for theta is pi minus pi over 6, or 5 pi over 6. Now remember, theta was replaced by 2x. So to actually find these values, 2x is actually equal to pi over 6, or 2x is equal to 5 pi over 6. Divide both of these by 2, and you get pi over 12, and 5 pi over 12. Now, how is this problem different from going from 0 to 2 pi for our values for x? Well, 2 sine 2x equals 1 has a horizontal compression by a factor of 2. So it is going to actually have a period from 0 to pi. So our period is pi units. So if we wanted to actually find out solutions from 0 to 2 pi, we'd have to take our original solutions, so on the interval from 0 to 2 pi, we'd have to take our original solutions of pi over 12 and 5 pi over 12 and add multiples, or add periods of that function. So pi over 12 plus pi would give us our next solution, and 5 pi over 12 plus pi would give us our another solution. Just by adding periods of whatever that function is, in this case pi, or subtracting it, would give you values in other domains. So let's use that to solve this kind of problem. The distance from a point on a water wheel as time increases follows the model -3 times cosine t minus 1 plus 2, where h of t is the height in meters above water at t seconds. Determine the times between 2 and 10 seconds where the water wheel is at water level. So in order for it to be at water level, and and this is the height above water, we're looking for the height when it's equal to 0. Okay, so I can subtract 2 off of both sides. I can divide by 3, -3, sorry. So I get 2 over 3 equals cosine of t minus 1. So that means t minus 1 is equal to the cosine inverse of 2/3. Well, remember, you can change this into a theta to find the two possible outcomes here. So cosine is positive in 2 quadrants. If you take cosine inverse of 2/3, you get 0.841. So one value of theta is 0.841. Another possible value for theta would be 2 pi minus 0.841. Which is approximately 5.442. Now remember, these original questions were t minus 1 equals these values. So one possible answer would be 1.841, or another possible answer would be 6.442. Now, we only wanted to find out the times between 2 and 10 seconds. Well, our first answer actually doesn't fit in that domain. The second one does. The question is, are there any others? Well, the period for this function is 2 pi, because this doesn't have a horizontal stretch or compression. So if we take 1.841 and we add 2 pi, we'll get another possible solution for a value for t, which is 8.124. So this will occur at these 2 times. And thus concludes this lesson.